I'm Mike Quinn, and this is another edition of LM76 On Air. Today, my guest is Anders Thorman from Ceramic Speed, a singular designer and manufacturer of ceramic hybrid bearings. Today, we'll be discussing Ceramic Speed rebuilding of motor bearings, taking standard motor bearings and replacing the steel balls with their unbelievable, indestructible silicon nitride balls. Good morning, Anders.
Morning, Mike, and thanks a lot for having me on. I'm delighted.
You know, I've seen the video where you do a hammer test that pulverizes, turns a silicon nitride ball to dust. Then you do a hammer drop on one of your balls and it's unaffected. Not only is it unaffected, it leaves an impression on the anvil. That's pretty amazing. And when I saw it, it was hard to believe.
Yeah, you're right. It's a very visual and very fantastic demonstration. I think it tells us two things, and it tells us two things that we want to convey to everyone listening. First thing, of course, is that the ceramic balls, the real good quality silicon nitride balls, they are really amazing. They are really hard, they're really light, they can do a lot of amazing stuff. But the other one is, of course, the risk that getting lower quality ceramic balls, could be silicon nitride, could be other ceramic materials, is a huge risk.
The other thing, can you just explain arcing and what that does to not only the ball, but also to the ball path?
Yeah, that's interesting. So basically, the biggest single customer group we have are electric motor customers. So it could be OEMs, it could be electric motor repair shops, and of course end users repairing their own electrical motors. The single reason for that is exactly what you're saying here, is this problem of electric arcing. So electric arcing is actually the phenomenon that if you put a voltage across the bearing, so basically a voltage going from rotor to stator or vice versa in the electrical motor, it will go through the bearings. And if it does so, you'll create a small welt between the steel ball and the steel raceway. I can show you here. I have an example here. I don't know how good it will be on the camera, but looking at inside this bearing, you might be able to tell here a black line. And
Absolutely,
this black line is actually made of several small cross lines. We call them barcodes, someone call them zebra stripes, but anyway, that's a clear indication that you have had electrical currents across the bearing. In a steel bearing, this creates these small welds, and the welds create a pattern, and the pattern, of course, is a function of revolution, so speed of the shaft, and then of course frequency of the current, and also the current amplitude. So this is a huge problem. This could kill a normal steel bearing in a matter of weeks. So we see everything down from 10, 12 weeks and up to 1 year, depending on motor size and speed and so on. So it's a huge problem out there.
So would you say that that's the major failure mode of motor bearings?
Yes, I would indeed, and it's actually an increasing problem, and it's an increasing problem down to obviously the very good aim in the world to save energy. So every new machine today, every new application out there is built with a variable speed drive. Because if you only need 500 RPMs, you shouldn't use a 1500 RPM motor. So what the variable speed drive does, these high frequency converters, they are called, is that they induce a high frequency current into the system. And it's really difficult to insulate against these high frequency voltages because they are high frequency. A thin layer insulation will not stop them. We see that a lot. So this problem is just increasing with technology, with higher frequencies, with more applications, with frequency converters, and this is killing bearings across the world. So yes, that's the number one, let's say, bearing failure mode for I would say modern electrical motor bearings today. And when you reduce friction, obviously you save energy. We actually did a study here. We had an external university to support that, and it was partly funded by the Department of Energy here in Denmark. So we had a report made to show the difference on an electrical motor with hybrids and electrical motors with standard bearings. So if you compare bearings, one bearing with the other, you could prove a 48% energy saving in the bearing resistance alone. Obviously, that's not the only losses. The bearing losses are not alone in the electrical motor. Actually, the biggest losses are from thermal losses and electrical losses. But anyway, even this small contribution of the bearings could increase your efficiency on the motor with a factor of 0.55 to 0.7%. But running with less friction also means running at a lower temperature. And as you know, Mike, a lot of electrical motor bearings today, they are cartridge type bearings, so they are sealed and greased for life. You cannot relubricate them. They're supplied with a grease filling inside that will last until the bearing ceases to work. So this means basically the bearing life is determined by the grease life, the grease inside the bearing. And then talking to the specialists, what we do on lubrication from Mobil, from Klüber, from other good people around the world, rule of thumb is that if you increase bearing temperature by 15%, you halve the bearing grease life. That's the nature of bearing grease and oil. So the bearing grease, it ages with temperature and with speed. So if you increase temperature by 15 degrees, you halve the grease life. So think of that in the opposite direction. If we can reduce the bearing temperature by 15%, we actually double the grease life of the bearing. And this, in some motors, particularly smaller motors, this actually means that effectively you double the bearing life just because of the lower running temperature. So that's a funny fact that actually pays a lot of bills.
As far as sealing goes, what are the options relative to sealing?
Yeah, so traditionally you'll get a lot of electrical motor bearings with these set shields, two set usually, and the set shield is a shield. It's not a seal, it's a shield. So it's made out of metal, thin plate metal, and it's put into place in the bearing with a spring mechanism, but it actually has a gap towards the rotating inner ring. So it's not a seal, it's a labyrinth, you could say. We prefer to use rubber seals. And again, to save energy, we use a low friction rubber seal, which have a very, very light contact on the inner ring, but it's a much better seal than the traditional shields. And doing that, we also we sort of retain a lot of lubricant in the bearing, especially I would say for applications with vertical shafts or vertical built-in shafts. You will lose a lot of lubricant through a traditional shield, but with the better rubber seals, you retain the lubricant inside the bearing for a long time without compromising the low friction of the bearing. So this is our recommendation to any customer. But obviously, you could have parameters requesting one or other seal, but this would be our standard recommendation for a motor seal, the RZ low friction rubber seal.
Another question I have is, because the balls are harder, rounder, smoother, and less weight than a steel ball, can we get higher RPMs, higher speeds out of a ceramic hybrid bearing?
But you're completely right. So the ceramic ball here, now I have one ball, same size each hand. One is ceramic, one is steel. So what any viewers cannot tell is that the steel ball is only less than half the weight of steel. So the ceramic ball is half the weight of a steel ball. And this lower weight obviously induces smaller forces inside the bearing when rotating. So when you spin a bearing or spin a ball with a high speed, you obviously create these centrifugal forces. And these forces are only half from the ceramic ball because of the lower weight. So again, rule of thumb is that with same bearing with ceramic balls, you can increase speed by around 40%. And Mike, we shouldn't forget to say that we came from the problem of electric arcing in bearings. And obviously this problem is solved with a ceramic ball here again. being a non-conductive material. This is non-conductive in the sense that the resistance of the electrical resistivity of ceramic material is higher than that of air. So no bearing current will run through a hybrid bearing ever. And this brings us to the price. This is one of the questions we often get at the first meetings with a new customer, like you would have tried yourself. And obviously, a hybrid bearing is more expensive than the standard bearing. The production cost of the ceramic balls is quite extensive, and that's more or less driving the cost of the bearing. So if you imagine a standard ball bearing, you should maybe multiply with a factor of 5 to 10, depending on size and volume and so on. So the standard the hybrid bearing would be a factor of 5 to 10 more expensive. But again, if you're talking about a bearing worth 100 euro or US dollar versus a 1,000 US or euro bearing, it makes no difference if you have to start a helicopter to replace it. And it makes no difference in your FDA customer environments where they would take 2 guys 6 hours or 8 hours to replace bearings, not producing milk or cheese or yogurt in the same time. So this production output and the manpower and the hours you put in, it always, goes far way beyond the cost of the bearing. So we actually do, with some customers, we do this calculation. We try to calculate the return on investment. So we take, the extra investment of the hybrid bearing versus the cost that you save. And it always turns out that first or second time, you should have replaced your standard bearings and you don't. The price of the hybrid bearings are more than paid for. So, and then you can extend it to number 3, 4, 5, 6 times, and you save a lot of money. So it's actually a good exercise to do. And I just want to recommend everybody out there to see beyond the purchase price of the product.
Well, your claim or boast, if you will, that you're going to increase the life of a bearing by 4 to 8 times, that's something you don't see every day.
Exactly, and we are actually quite conservatively using those numbers, so 4 to 8 times service life. We have documented cases where we have increased service life by a factor of 44, so from 11 weeks to 11 years to be exact. That's really a bad business case for us. It was a fantastic business case for the customer, but obviously we cannot do that every time. I have to admit. But it's in the environments that we're talking about here, where you have wet environments, you have the wash downs, like you know well yourself. If you have the electrical problems and so on, we always come in and give a minimum improvement of a factor of 4. So a factor of 4 to 8 is I would say it would be the bulk of our bearing applications out there. So that's it sounds bold, but it's reality. So we're quite comfortable saying that. Working with LM76 obviously is a fantastic opportunity for us, opening up the US market with the same mindset what you have.
Well, listen, Anders, I want to thank you for your time today. This has been great. Any questions that you might have out there as the audience, please feel free to give me a call, 1-800-513-3163, or send me an email at mquinn@lm76. Anders, thanks again.
Fantastic. It's a pleasure being here. So thank you for setting this up, and have a great day in the US.
You too. And I want to thank everyone who's watching. And again, any questions, feel free to call us. Ceramic Speed is a singular company with a singular product and a singular reputation. Thanks. Bye-bye.
Thank you. Cheers.